Hi everyone. So let's now go back and forth between radical form and exponential or power form. And what are the corresponding domain restrictions? Real values of x that would work to keep things real. Okay, so the square root of x, the principal square root of x, is x to the what? And we only take the principal square root of what kinds of real values of x to keep things real. The square root of x is x to the 1/2, and we only take square roots of non-negative real values. So you have a little checklist here. If you have something involving x, right? Can x be positive? Yes. Can x be positive? Yes. The square root of 0 is 0. That works out. Can x be negative? No. We do not take square roots of negative values if we want to keep things real. All right. What about the cube root of x? The cube root of x. That's x to the what? And are there any restrictions? The cube root of x is x to the 1/3, but we can take cube roots of, well, positive values. We can take the cube root of 0, that's 0, and we can take the cube root of a negative number. The cube root of -1 is -1, for example. So we can take the cube root of any real value. There are no restrictions, assuming that x is real. We're assuming x is real. All right. Next up. Oh, and by the way, in case you forgot that, I'll refer you to my old notes. Refer you to my old notes over here. Remember, the square root of x is under right under part B. The square root of x is also written as x to the 1/2, the principal square root of x. And remember, the nth root of x is also written as x to the 1/n. So for example, the cube root of x is x to the 1/3. The fourth root of x is x to the 1/4. Don't confuse these with negative exponents. So remember, x to the 1/2 is the principal square root of x, but x to the -2 is what? X to the -2 is 1/x². A lot of people mix these up. Remember, fractions tend to correspond to radicals. Negative exponents tend to correspond to fractions. All right, moving on. This guy here. 3 times the 7th root of x to the 5th, or 3 times the 5th power of the 7th root of x. It turns out these are equivalent. Now, why am I putting parentheses, by the way? Not just to distinguish between these two expressions, although they are equivalent, but there's another reason. If I didn't have parentheses, what are you in danger of mistaking this for? I think a lot of students might be in danger of mistaking it for this. 3 to the 7th all times the square root of x to the 5th. If you saw something like this, right? Aside from the fact I have messy screenwriting, is this the 7th root or is it 3 to the 7th? Which is it? So when in doubt, if there's ambiguity, put grouping symbols, all right, to be safe. Trust me, in this pre-calculus class and later on, grouping symbols are really your friend. When in doubt, put grouping symbols. You have no idea how important they are and how often they'll save your skin. Anyway, back to the main point at hand. So now, what is this? Writing 3 times what power of x? All right, we have the 3, that's just that coefficient out there, times x to the what? Either way, it's going to be x to the 5/7. X to the 5/7. 5 indicating the power, 7 is the root index. 3x to the 5/7. Now, are there any restrictions? Well, let's look at these 3 cases. If x is positive, any trouble there? You might want to look at the radical form. Well, the 5th root of a positive number is positive. The 5th power of a positive number is positive, and the 7th root of a positive number is positive, real. So we're good there. How about 0? Well, power of 0 is 0. Root of 0 is 0. That's fine. How about negative? The fifth power of a negative number is negative. The seventh root of a negative number, not a problem. It's a negative real number. It's all good. All reals. No restrictions on the domain. 3x to 5/7, no restrictions. Okay, next up, we're going to look at combinations, combined forms. 1 over the square root of x. 1 over the square root of x. So that's going to be what? X to what exponent in the end? Well, we have 1 over the square root of x is x to the 1/2. And then x to the 1/2 can come up or come out as x to the what? As x to the negative 1/2. So we have both a fraction and a negative sign in the exponent. And what are the restrictions? What are the restrictions? It might help to look at this combined form with the radical. All right, what are the restrictions? Okay, well, let's look at these three cases. Can x take on these various values of x? Can x be positive? Sure. Not a problem there. Can x be 0? The square root of 0 is 0. The problem is that we'd be dividing by 0 in that case. So that, my friends, is no good. Can x be negative? The problem there is not so much the fraction, it's the fact that we have what kind of root? We have a square root, and we don't take square roots of negative numbers and keep things real. So that's no good either. X has to be positive in value. Oops. X has to be positive in value. All right. So we have x to the negative 1/2. X has to be positive in value. All right. Now, what about 1 over the cube root of x? How's that going to be similar and different? 1 over the cube root of x. That's going to be x to the what? And what restrictions are there? All right. So we're going to have here 1 over, well, the cube root of x is x to the 1/3. Again, that can pop out or up. If you're popping from, if you're hopping from bottom to top, you can also go from bottom to out. Bear in mind that if you have a negative exponent on top, then you gotta be more careful. All right, but x to 1/3 on the bottom basically goes up to x to the negative 1/3 out or on top. All right, so we have x to the negative 1/3. And what are the restrictions? Okay, well, here are the various possible values of x. Okay, can x be positive? Not a problem. Can x be 0? Well, then you're going to be divided by 0 in the end. That's no good. Right. Can x be negative? Actually, the cube root of a negative number is negative. That's okay. Move this up a bit. All right. The cube root of a negative number is okay. 1 divided by a negative number, that's not a problem. That's a negative real number. That's actually okay. That's actually okay. So x cannot be 0. That's the only restriction. We have x to the negative 1/3. X cannot be 0. Now this doozy here. 7 over the 4th root of x to the 3rd. All right. 7 over the 4th root of x to the 3rd. All right. That's going to be 7, or 7 over 1, if that helps. 7 or 7 over 1 times 1 over the 4th root of x cubed. Nice save there. All right, 1 over the 4th root of x cubed. All right, now 7 over 1 is just 7. All right. So the 7 can pop out easily. Any factor on the top can pop out easily. All right. It's that whole negative exponent trick that you got to be kind of careful. But the 7 on the top as a factor at the top, that pops out as a 7. All right. Times, what's this? It's going to be x to the what? X to the negative 3/4. Why x to the negative 3/4? Why negative up here? Why negative? Because this is in the bottom. It's a factor of the bottom. Why the 3? Because that indicates the power. Why the 4 down here? It indicates 4th root. 7x to the negative 3/4. And then for the restrictions, look over here in this radical form over here. All right, let's go through these cases. Can x be positive? Cubing a positive gives a positive. 4th root of a positive is positive. Dividing by a positive, no problem. Positive values for x, not a problem. Can x be 0? That bottom turns out to be 0. Answer is no. Maybe I shouldn't use x to mean wrong here, but you get the idea. All right. What about x being negative? How about that? X being negative. Well, the cube of a negative number is negative, but then the 4th root of a negative number, that's no good. Got to be positive. X has to be positive. 7x to the negative 3/4. 7x to the negative 3/4. All right. This is your bread and butter in calculus. Because trust me, if you want to take the derivative or the integral of something like this guy, you're going to want to write it out like this and not like in the radical form. Because we have nice rules for differentiation and integration if you're dealing with these kinds of expressions. Rewriting expressions is a key part of calculus. For some people, that's the tricky part. Next up, let's use the rules for exponents and radicals to simplify expressions. More complicated expressions like these. Next time.